Electricity in a barn follows the same rules as electricity in a house. The wire has to get from the panel to the outlet. It has to be protected inside conduit or cable sheathing. It has to follow a route that meets code, proper clearances from water sources, proper separation from flammable materials, proper support every 4.5 feet. The rules are the rules, and the electrician who follows them produces a safe, inspectable, code-compliant installation that passes the county electrical inspector's review without a callback. The problem with barns is that barns weren't built to be wired. A house has stud walls with cavities for running cable. A barn has solid timber frames, posts, beams, and braces, joined together with mortise and tenon joints that were cut and fitted by hand, in some cases 150 years ago, and that contain no cavity, no chase, no hollow space where a wire can hide. Running wire in a timber frame barn means running it on the surface, exposed conduit strapped to the beams, following the frame from panel to outlet in a series of straight runs and 90-degree bends that navigate around posts, braces, doors, windows, and the accumulated structural complexity of a building that was designed to hold hay, not circuits. Most electricians can do surface conduit work. It's straightforward. Measure, cut, bend, strap, pull wire. The bends are the skilled part. Every direction change requires a bend in the conduit, a precise, smooth curve that maintains the conduit's internal diameter so the wire can be pulled through without binding. A bad bend, too sharp, kinked, collapsed, creates a point where the wire jams during the pull and the whole run has to be redone. Good bends are the mark of a journeyman. Perfect bends are the mark of an artist. In the fall of 2002, a farmer named Willis Dalton needed to wire the loft of his barn outside of Glasgow, Kentucky. The barn was an 1887 timber frame bank barn, built into a hillside, stone foundation on 3 sides, the upper level a hayloft with a threshing floor, the lower level a stable with stalls for cattle and horses. The barn was 60 feet long and 40 feet wide, with a post and beam frame made from white oak timbers that were hand-hewn in 1887 and still as sound as the year they were cut. Willis wanted 4 20-amp circuits in the loft, overhead lights, receptacles for power tools, and a 240-volt circuit for a welder. The main electrical panel was on the ground floor, on the south wall of the stable. The wire had to travel from the panel on the ground floor to the loft above, a vertical run of 12 feet through the floor structure, and then horizontally through the loft to 4 outlet locations along the walls. The vertical run was the problem. Between the ground floor panel and the loft above was the floor structure, a solid mass of 8 by 10 white oak joists, 2 layers of oak planking, the ground floor ceiling and the loft floor, and a stone wall that separated the stable from the bank where the barn met the hillside. There was no existing penetration, no existing conduit chase, no hollow wall cavity. The only route from the panel to the loft was either through the floor structure, which would require drilling through 150-year-old white oak joists, or through the stone wall, which would require core drilling through 2 feet of hand-laid limestone. Willis called an electrician, Dale Rigsby, a licensed master electrician out of Glasgow, who'd been wiring farms for 22 years. Dale looked at the barn. He looked at the floor structure. He looked at the stone wall. He made his assessment in the professional language. of a man who sees a problem he can solve only one way. Mr. Dalton, I can't run conduit through that floor structure without opening the ceiling. The joists are 8 by 10 on 16-inch centers with 2 layers of planking. There's no space between the joists for conduit. The planking is tight to the bottom of the joists. I'd have to remove a section of the ground floor ceiling planking, drill through 2 joists, run the conduit through the joist bays, and replace the planking. Or I can core drill the stone wall, but that's a masonry contractor, not an electrician. How much to open the ceiling? The ceiling work, the drilling, the conduit, the wire, the outlets, the whole job is approximately $4,800. About $1,200 of that is the ceiling, tear out, and replacement. The oak planking is 135 years old. I can't guarantee I can remove it without splitting it, which means I might have to replace it with new oak, which adds another $400 to $600. $5, $400 to wire a loft. And you're going to tear into my grandfather's ceiling to do it. I don't see another route. The conduit has to get from the panel to the loft. The only path is through the floor structure, and the floor structure is solid oak with no cavity. There's another route. Where? Outside. Stay with me, because what Willis saw that Dale didn't, and the conduit route he ran with hand-bent EMT and a pipe bender he'd been using since the Kennedy administration, is why this story is about seeing the space the professional wasn't trained to look for. Let me tell you about what Willis meant by outside, because the route he'd identified was not obvious and not in any electrician's playbook, and the reason he saw it was 40 years of walking around his barn every day and knowing every crack, every gap, and every inch of space that existed between the visible structure and the invisible air behind it. The barn's south wall, the wall where the electrical panel was mounted on the ground floor, was stone on the lower level and timber frame with vertical board siding on the upper level. The transition between stone and timber happened at the floor line. The top of the stone wall supported the timber sill, and the timber frame rose from there to the roof. At the transition point, where the stone met the timber, there was a gap. Not a big gap, 3 inches. The stone wall was 2 feet thick. The timber sill was 10 inches wide. The sill sat on the inside face of the stone wall, leaving approximately 14 inches of exposed stone top on the outside face. The vertical board siding on the upper level was nailed to the outside face of the timber posts, which were set back from the stone wall's outer face by about 3 inches. That 3-inch setback created a void, a narrow channel between the back of the siding boards and the top of the stone wall that ran the full 60-foot length of the south wall. 3 inches. Enough for a 3/4-inch EMT conduit with room to spare. A channel that ran from the ground floor to the loft level without penetrating a single joist, a single plank, or a single stone. The conduit could travel vertically up the outside of the stone wall, protected by the siding, enter the void at the stone-to-timber transition, and emerge inside the loft through a hole drilled in the sill plate. 1 penetration, 1 drill hole. 0 damage to the 1887 floor structure. Willis had seen this gap because he'd been looking at this wall for 40 years. He'd pushed his hand into it as a teenager, feeling the cold air from outside, wondering why the barn builders had left the space. The answer was practical. The siding was nailed to the posts were set on the sill, and the sill was narrower than the stone wall. The gap was a construction artifact, not a design feature. Nobody had intended to create a conduit chase. But there it was, 3 inches of vertical space, 60 feet long, invisible from the inside and protected from the weather by the siding on the outside. If you're enjoying this story, consider subscribing to The Average Farmer. We share stories like this every week. Dale Rigsby didn't know about the gap. He'd looked at the barn from the inside, from the floor structure, from the ceiling, from the stone wall. He'd looked for roots through the building. Willis was looking for roots around the building, using the spaces between the structure and the skin, the voids that exist in every old building where the framing meets the cladding, and the cladding doesn't quite fill the space. There's a 3-inch void between the siding and the stone wall on the south side. It runs from the foundation to the sill plate. I can run conduit up the outside of the stone, through the void, and into the loft through a single drill hole in the sill. No ceiling tear-out, no joist drilling, no masonry work. A 3-inch void behind the siding. Come outside, I'll show you. Willis led Dale to the south wall of the barn. He pried a siding board away from the post, gently, a 1/4 inch, enough to see into the space behind. The gap was there, 3 inches of air between the back of the siding and the face of the stone wall, extending from the foundation stones at ground level, upward to the sill plate at the loft floor level, 12 feet of vertical channel, 3 inches deep, 60 feet long, a conduit highway that the electrician had been standing 6 inches from and hadn't known existed. Dale looked into the gap. He reached his hand in cold air, rough stone, the back of century-old siding boards. The space was tight, but consistent. No obstructions, no cross-bracing in the void, just air and stone and the back of boards. I can run 3/4 EMT in that space. It's tight. I'll have to pre-assemble the conduit runs on the ground and feed them up from the bottom, but it's doable. It's more than doable. My father ran a water pipe through the same gap in 1968 to feed a hydrant at the loft level. The pipe is still there. I'll show you. Willis showed him. A 1/2-inch galvanized water pipe running vertically through the void from the ground floor hydrant to a frost-free hydrant at the loft level. Willis's father, Orrin Dalton, had run the pipe in 1968, using the same gap that Willis was now proposing for the electrical conduit. The pipe had been in the void for 34 years, protected from freezing by the stone wall's thermal mass on one side and the barn's interior warmth on the other. The gap wasn't just a conduit route. It was a proven utility chase with a 34-year track record. Everything was about to get done without touching a single 1887 timber. But Willis had one thing the electrician didn't: 40 years of knowing his barn's secret spaces. Let me tell you about the conduit work, because Willis didn't just show Dale the route. Willis bent the conduit himself. And the quality of the bends is where this story shifts from a routing problem to a craftsmanship story. Willis had been bending EMT conduit since 1964. His father, Orrin, had been a part-time electrician, a farmer who wired barns, houses, and chicken coops for neighbors, in addition to running his own 180-acre cattle operation. Orrin had taught Willis to bend conduit the same way he'd taught him to shoe a horse, by feel, by eye, and by the understanding that the material has a will of its own, that you work with instead of against. The tool was a hand bender, a simple lever device that clamps onto the conduit and allows the operator to bend it by applying foot pressure to the bender's pedal while pulling back on the handle. No hydraulics, no electricity. Leverage and muscle, and the understanding of how far to pull for a 90-degree bend versus a 45 versus a 30 versus the compound offsets and saddle bends that separate a technician from a craftsman. Willis's bender was a Klein Tools 56207, a hand bender that Orrin had bought in 1961 for $12, 41 years old. The handle was worn smooth from 4 decades of hands. The shoe, the curved surface that contacts the conduit during the bend, was polished from thousands of bends. The degree markings on the bender's head were worn faint but still legible. The tool was as much a part of the Dalton farm as the Farmall 560 in the barn. Willis measured the route. The conduit run from the panel to the loft required a 90-degree bend at the base of the stone wall where the conduit transitioned from horizontal to vertical, a straight vertical run of 12 feet through the void, a compound offset bend at the sill plate where the conduit entered the loft through the drill hole at an angle dictated by the gap width and the sill thickness, and then horizontal runs inside the loft to the 4 outlet locations, with bends at every post and brace that the conduit had to navigate around. Total bends, 23, 9 90-degree bends, 6 45-degree bends, 4 offset bends, 2 saddle bends where the conduit had to rise over a beam and return to the same level, and 2 compound bends in 2 planes simultaneously at the sill plate penetration, and at a corner where 2 beams met at a non-standard angle. Willis bent all 23 by hand in an afternoon. He worked on the threshing floor, laying out the conduit runs, marking the bend points with a grease pencil, calculating the bend angles from measurements he'd taken with a bevel gauge and a tape measure. Each bend was made in the hand bender, foot on the pedal, hands on the handle, pulling to the mark, checking the angle with the bevel gauge, adjusting with a slight additional pull if the spring back of the EMT had underbent the angle. The bends were clean, not just functional, beautiful. The 90s were crisp, with smooth curves and no kink at the apex. The 45s were precise, matching angles on paired bends within 1 degree. The offsets were symmetrical, the 2 bends of each offset at identical angles, producing a clean step in the conduit that looked machined rather than hand-formed. The saddle bends rose smoothly over the beam profiles and returned to level without a wobble. And the compound bends? The 2 bends that required simultaneous direction changes in 2 planes were the work of a man who'd been bending conduit for 38 years and could feel the EMT's yield, point through the bender handle the way a violinist feels the bow's contact with the string. The compounds curved through space like a river navigating terrain, smooth, continuous, no flat spots or sharp transitions. The EMT following a path that looked inevitable rather than forced. Dale Rigsby watched Willis bend the compounds. Dale was a master electrician with 22 years of experience. He'd bent thousands of feet of conduit. He could bend a 90 and a 45 and an offset in his sleep. But the compounds Willis produced, the fluid 2-plane curves that transitioned from the void into the loft, through the sill plate, at an angle that matched the gap geometry exactly, were beyond what Dale could produce with confidence. Where did you learn to bend compound curves? My father taught me in 1964. He'd learned from a union electrician who'd wired the Fort Knox barracks during the war. The Army electricians bent compound curves because military construction had non-standard angles everywhere: Quonset huts, ammunition bunkers, underground rooms with angled walls. If you couldn't bend a compound, you couldn't wire the building. My father learned it in the barracks and brought it home to Barron County. I was trained in a vocational program. We learned 90s, 45s, offsets, and saddles. Nobody taught compounds. The textbook said to use a preformed fitting for any bend that requires two-plane deflection. A preformed fitting costs $8 and looks like a tumor on the conduit. A hand-bent compound costs nothing and looks like the conduit was born that way. The fitting is a solution for electricians who can't bend. The bend is a solution for electricians who can. That moment changed how Dale thought about conduit work. And the 23 bends in that barn, visible today, every one of them, have never needed adjustment or replacement in 22 years. Let me tell you about the installation, because the conduit went in over 2 days, and the electrical inspector who came to approve it couldn't stop looking at the bends. Willis and Dale installed the conduit together, Willis feeding the pre-bent runs up through the void from the ground level, Dale receiving them inside the loft and strapping them to the timber frame. The void installation went smoothly. The 3-inch gap accepted the 3/4-inch conduit with room to spare, and Willis used a fish tape to guide each run from the bottom to the top, pulling the conduit up through the channel like threading a needle. The sill plate penetration, the compound bend that transitioned from the vertical void to the horizontal loft, was the critical piece. Willis had measured the sill thickness, 10 inches, the gap width, 3 inches, the entry angle, approximately 22 degrees from horizontal, and the exit angle, horizontal, and had bent the compound to match. The conduit entered the drill hole in the sill at 22 degrees, curved through the sill's thickness in a smooth compound arc, and emerged inside the loft horizontal and straight, ready for the horizontal runs to the outlets. The fit was perfect. The conduit slid through the sill hole with a 1/4 inch of clearance on all sides. The compound curve maintained the conduit's internal diameter. No restriction, no kink. The wire pull would be clean. Dale pulled the wire through the entire run, 120 feet from the panel to the farthest outlet, in one continuous pull, without a single jam, because every one of Willis's 23 bends was smooth enough to let the wire slide through without catching. The county electrical inspector, a man named Ray Sowers, came on a Thursday. He inspected the conduit runs, the wire fill, the connections, the grounding, the panel terminations. Everything was code compliant. Everything was clean. But Ray spent more time looking at the conduit bends than at the electrical connections. "Who bent this conduit?" "The property owner," Dale said. "Willis Dalton. These compounds at the sill plate, these are hand-bent?" "Hand-bent with a Klein bender from 1961. Ray ran his hand along the compound bend, the smooth two-plane curve that transitioned from vertical to horizontal through the sill plate. The EMT was unmarked, no scratches from the bender shoe, no deformation at the apex, no evidence of rework or correction. The bend looked like it had been formed in a factory jig. I've been inspecting electrical for 14 years. I've never seen hand-bent compounds this clean. Most electricians use fittings for two-plane transitions because they can't bend compounds without kinking. This is exceptional work." His father taught him. Army electrician technique from the 1940s. The Army taught this? The Army taught my father, Willis said from the loft. Fort Knox Barracks, 1943. Non-standard angles in every building. If you couldn't bend a compound, you couldn't wire the fort. My father brought the skill home. I've been bending since 1964. Ray signed the inspection approval without a single deficiency. He told Dale afterward that the Dalton barn was the cleanest conduit installation he'd inspected in 14 years. Not because the wiring is unusual, but because the conduit bends are the best I've ever seen in a field installation. Most conduit work looks like plumbing. This looks like sculpture. If you're enjoying this story, consider subscribing to The Average Farmer. We share stories like this every week. Let me tell you about the JD dealer, because Clayton Frost enters this story the way every dealer enters. From the equipment angle, missing the skill angle entirely. Clayton ran the JD dealership in Glasgow. He didn't sell electrical equipment. He sold tractors and farm implements, but he was on the county agricultural committee with Willis, and he'd heard about the barn wiring at a committee meeting when Willis mentioned it as an example of maintaining historic farm buildings without destroying them. Clayton drove to the barn to see it. Not the wiring specifically, but the void route that Willis had identified. Clayton was interested because he'd been telling his customers for years that old barns should be replaced with steel buildings. Modern, easy to wire, easy to insulate, easy to maintain. The idea that an 1887 timber frame barn could be modernized with electricity without touching the original structure contradicted his sales pitch. Willis, I've been telling farmers to tear down their old barns and build steel for 20 years. I tell them the old barns can't be modernized, can't be wired, can't be insulated, can't be adapted for modern equipment, and you wired yours without removing a single board. Because I looked at the barn before I looked at the problem. The electrician looked at the problem, how to get wire from the panel to the loft, and saw a floor structure he couldn't penetrate. I looked at the barn, the whole barn, outside and inside, the gaps and the voids and the spaces where the structure meets the skin, and saw a route the electrician wasn't trained to see. The 3-inch void. Every old barn has voids, where the siding meets the frame, where the roof meets the wall plate, where the stone foundation meets the timber sill. These are the spaces that builders left unintentionally, and that electricians, plumbers, and insulators can use intentionally if they look for them. The professionals look at the structure and see obstacles. The farmer looks at the building and sees spaces. You're telling me every old barn in Barron County has hidden conduit routes? I'm telling you every old building in the world has spaces between the parts that were never designed for utilities, but that can carry them. The void behind the siding, the gap above the plate, the channel alongside the chimney. These spaces exist because buildings aren't monolithic. They're assemblies of parts, and the parts don't fit perfectly. The imperfection is the opportunity. Clayton looked at the barn. 1887 timber frame. White oak, hand-hewn. The same barn he'd been telling farmers to demolish for 2 decades. The barn was wired. It had lights, outlets, and a 240-volt welder circuit. The conduit was invisible from the inside, hidden in the loft's timber frame, strapped to the beams, following routes that the 1887 builders never imagined, but that their construction had inadvertently created. The barn was 115 years old and fully electrified without a single compromise to its original structure. I sell new buildings because I tell farmers the old ones can't be adapted, and you adapted yours with a $12 bender and 3 inches of air. You sell new buildings because new buildings are profitable for you. Adapting old buildings is profitable for the farmer. The difference is who benefits. When I wire my barn myself, using spaces that already exist, the barn gets better and my wallet stays full. When you sell me a steel building, the barn comes down, the steel goes up, and your wallet gets full. Same result, a wired building, different beneficiary. Let me tell you about the aftermath because Willis's void routing technique and his compound bend skill created a demand he didn't expect, and a second career he didn't want. Dale Rigsby told 3 other electricians about the Dalton barn, the void route, the compound bends, the inspection approval. 2 of them visited the barn to see the work. Both left with the same reaction. The void route was clever, the bends were extraordinary, and they wanted Willis to teach them the compound bend technique that their vocational training had never covered. Willis taught them, not in a classroom, in his barn, on Saturday mornings, with the Klein bender and lengths of scrap EMT that Willis had been collecting from job sites and farm auctions for decades. He taught the hand position, the foot pressure, the visual cues that tell you when the bend is at the right angle, and the feeling in the handle that tells you when the EMT is about to kink. He taught the Army method, the Fort Knox technique that his father had brought home in 1945, and that Willis had been refining for 38 years. 5 electricians learned the compound bend technique from Willis between 2003 and 2006. 3 of them now use it regularly in their commercial work. 1, a young apprentice named Dylan, who was 22 when he started learning from Willis, has built a specialty in historic building wiring, running conduit in pre-Civil War structures across central Kentucky, using void routing and compound bends that he learned in Willis Dalton's barn. I went to trade school for 4 years, Dylan told the Kentucky Electrical Association in 2010. I learned the NEC code, the wire tables, the circuit calculations. I learned to bend 90s and offsets. I never learned to bend a compound. I never learned to look for voids. I never learned that the space between the siding and the stone wall is a conduit chase. I learned all of that from a 74-year-old farmer who'd been bending pipe since Kennedy was president, using a bender his father bought for $12. Let me tell you how this ends. Willis Dalton farmed until 2010, when he retired at 82. His son, Frank, runs the 180 acres. The 1887 barn is still standing. Timber frame, stone foundation, vertical board siding, and a full electrical system running through voids that the original builders never knew they'd created. The conduit bends are still clean. 23 bends, not one of them sagging, loosening, or developing a kink in 22 years of service. The Klein 56207 bender is in the barn, hanging on a nail beside the Farmall 560. It's 63 years old. The handle is polished to a glass finish from 4 decades of Willis's hands and 2 decades of his father's. The shoe is worn thin from thousands of bends, but still functional. Frank uses it for farm wiring, not with Willis's skill, but with enough proficiency to bend a 90 in an offset and, when the occasion demands, a compound that his father would recognize as correct, if not quite as fluid. Dale Rigsby is still wiring farms in Barron County. He now checks for voids before he quotes a tier out. In the past 20 years, he's found usable void routes in approximately 1/3 of the old barns he's wired. 3-inch gaps, 4-inch channels, spaces between structure and skin that the original builders left behind and that modern electricians can use if they know to look. Each void route he finds saves the farmer $1,000 to $2,000 in ceiling or wall tear-out costs. Willis taught me to look at the building before I look at the wiring diagram, Dale says. The wiring diagram tells me where the wire needs to go. The building tells me how to get it there. Those are two different pieces of information, and the building's information is always more useful than the diagrams. Ray Sowers, the electrical inspector, retired in 2018. He keeps a photograph of Willis's compound bend on his office wall, the smooth two-plane curve where the conduit enters the sill plate. He shows it to every apprentice electrician who comes through his office for a permit. That's what a hand-bent compound looks like when a man with 40 years of field does it, Ray tells them. Your trade school teaches you to use a fitting. This farmer teaches you to use your hands. The fitting costs $8. The skill costs nothing and lasts forever. If this story stayed with you, subscribe to The Average Farmer for more. We'll see you in the next one. The electrician measured the wall. The farmer measured the space behind it. 3 inches of air between siding and stone. An accident of 1887 construction that became a conduit route in 2002 because one man had been looking at his barn for 40 years and knew where the spaces were. 23 bends, a 1961 Klein bender, an Army technique from Fort Knox, and a barn that got wired without losing a single 135-year-old board. Because the wire doesn't care which route it takes, it just needs to reach the other end. And the farmer who knows his building's secret spaces always finds a route the professional doesn't see.